The first thing that we're going to do is work just with the discriminant, and remember that the discriminant d is equal to b squared minus 4ac. So in example number 1, the first thing we want to do is identify our a, b, and c values. Our a value is equal to 1. It's the 1 that's implied in front of that b squared. Our b value is 34 and our c value is 289. So we are going to say that d is equal to b squared, so that's 34 squared, and then minus 4 times a, which is 1, and times c, which is 289. Let's calculate what this is going to be, and when I put this into my calculator, I'm going to get a d value that's equal to 0. I get a d value equal to 0 because 34 squared is 1156, and 4 times 1 times 289 is also 1156, so that's equal to 0. What does that mean? It means that we have one real solution because we have d equal to 0. How do I know that? I'm going to go back to the original page that we were on, this front page, and when d is equal to 0, we have one real solution. Let's take a look at our second problem, and the first thing that I notice is that this is not in standard form. We have one piece of our equation on the left-hand side and two pieces on the right. Let's go ahead and move the things that are on the right over to the left so that I can keep that positive value in front of x squared. So I want to subtract 3 from both sides of the equation, and I want to add an 8x to both sides of the equation. This will cancel, leaving me with still my x squared. Remember that we want to write this in standard form as we go along, so I'm going to say plus 8x next, and then minus 3 is equal to 0. And now I'm ready to identify a, b, and c. A is equal to the 1 that's implied in front of x squared, b is 8, and c is negative 3. Let's go ahead and plug into our discriminant equation now. D is equal to b squared, so that's 8 squared, and then minus 4 times 1 times negative 3, and we want to continue solving. So D is equal to 64 plus 12, because negative 4 times 1 times negative 3 is going to give me a positive 12. So this is all equal to a positive 76, so we have a D that is greater than 0, and that means, looking at our chart on the front page, that we have two real solutions. I'd like for you to try number 3 down here, and then come back to see if you came to the same conclusion that I did. Looking at problem number 3, I noticed that I'm not in standard form. I need to move this 3q over to the left-hand side with everything else. So I'm going to subtract 3q from both sides so that it will cancel on the right and move it to the left. Remember to write in standard form as you rewrite the equation. So 4q squared minus 3q plus 1, and you can then identify your a as 4, b is negative 3, and c is 1. Plugging into my discriminant equation with b squared, which is negative 3 squared, and then minus 4 times a times c, 4 times 4 times 1. That's going to give me 9 minus 16, or negative 7. Negative 7 is less than 0. It's negative, so that means that I have two imaginary solutions for this problem.